Hello and welcome back to my channel. In this video I'm going to cover the angle of elevation and depression, which is a subtopic of the trigonometry. This comes under applications of trigonometry. Now applications of trigonometry is if you want to find out the height of a building, or if you want to find out the distance between a person and a mountain, how much he has to walk to reach the mountain, so and so. So in these cases we are going to use the applications of trigonometry using angle of elevation and depression. Now to begin with, consider that you're looking straight as a horizontal line. So if you're standing over here and you're looking straight, now this straight line is called as line of sight. Line of sight, or I will write it as LOS, the abbreviation. Now if apart from this horizontal line, if you are looking at a bird which is flying above, for example if I draw a line over here, so you're looking at a bird which is flying above, so the angle made with the line of sight and the bird by your eyes is called as angle of elevation. Now when you're looking up, the angle made is called as angle of elevation. Let me write the abbreviation as AOE. Now think that you are on a bridge and there is a ship which is going below and you're looking at it. That is, you're looking at a ship which is going down. Now the angle your eyes makes with the ship when you're looking down is called as angle of depression. So this is the only basic thing you have to remember. When you look straight, this is called as the line of sight, and if you are looking above with respect to the line of sight, it's called angle of elevation, and if you are looking below with respect to the line of sight, we call it as angle of depression. Now let me give you another case where a person is standing on the ground and there is a person who is standing on a mountain. For example, this is a mountain and the person is standing over here. Now in this case, the person standing on the ground, let me take it this way, and he looks on top. That is, he is making an angle of elevation with respect to the line of sight, because this is his line of sight. So this becomes the angle of elevation of the person on the ground with respect to the person on the mountain. Now think that the person who is on the mountain is looking at the person who is on the ground. Now if he is looking below, then we know that it is angle of depression. But before we know how to draw the angle of depression, remember to mark the line of sight, because angle of elevation and angle of depression is always with respect to the line of sight. So this is the line of sight for the person who is standing on the mountain and he is looking below. So with respect to the line of sight, this becomes your angle of depression. Now if you look carefully, this forms a kind of alternating angle, and the property of alternating angle is the angles are going to be the same. So if angle of depression is 30 degrees, then angle of elevation is also going to be 30 degrees. These are called as Z angles as well, or alternating angles. Now these are the basics you need to know to solve the examples, the word problems related to angle of elevation and angle of depression. Now let us start with the examples. Now the first example says, Brian's kite is flying above a field at the end of 65 meters of a string. So the length of the string is given as 65 meters. If the angle of elevation to the kite measures 70 degrees, this is the angle of elevation, how high is the kite above Brian's head? Now I will suggest you to always make a rough diagram before you start with the calculations, because that will give you an idea what exactly is being asked in the question. Now Brian has a kite, so let me draw a kite here. Brian's kite is flying above a field at the end of 65 meters of a string. So they are saying that it is flying above a field. For example, Brian is over here, so it is flying on this. So let me take it as a straight line to reduce any confusion. So this is the length. Now they have given that the length of the string is 65 meters. So the length of the string which is tied to the kite is 65 meters. Next, if the angle of elevation to the kite measures 70 degree. Now, since angle of elevation is given, make sure that you are drawing the line of sight first. And as we know, line of sight is always a horizontal line, and Brian is over here. So this is the line of sight. And Brian is looking on the kite which is on the top, making an angle of elevation of 70 degrees. How high is the kite above Brian's head? Now if this is Brian's head, they are asking you what is the height between the kite and Brian's head. That means this is what they are asking for. This is our x, that is the unknown which we need to find. Now as you can see, this makes a right angled triangle. It becomes really easy for us to use the trigonometric ratios to find the height, which is x. Now if you want to know how to find the trigonometric ratios, I have uploaded a video and I will put the description link of the video, so you can refer it and go through the steps I have explained if you have any confusions understanding this question. Now, since we have to find out the height and the angle of concern is given over here, our next step is to write down which is opposite, which is hypotenuse, and which is the adjacent. As I had explained in my previous video in the basics of trigonometry, we always start by marking the hypotenuse, and hypotenuse is always opposite to the 90 degree angle. So if this is the 90 degree, opposite to that is 65 meters, hence this becomes the hypotenuse to us. The next side which we start to mark is the opposite, and the opposite side is always opposite to the angle of concern, and here the angle given is 70 and opposite to that is our x. So this is our opposite side, and the default side which is unmarked can be marked as adjacent. Now after marking the hypotenuse, opposite and adjacent, next thing comes is the calculation. Now we have to check whether so works, or whether ka works, or whether toa works, where so is sine equals opposite over hypotenuse, ka is cos equal to adjacent over hypotenuse, and toa is tan equal to opposite over adjacent. So let us see what all can be used. Let us see first if sine can be used, where opposite and hypotenuse is given. So if we use a sine of 70 equals opposite, so opposite is the x which we need to find, one unknown we have, and the hypotenuse which is 65. So is going to work here, so we are going to stick on to the so we can write sine of the angle of concern which is 70 degrees is equal to the opposite is x divided by the hypotenuse which is 65. So we can find x equals, now 65 multiplies with the sine 70, so it becomes 65 multiplied with sine 70. So let me use the calculator here to see what answer we get. So we have 65 multiplied with sine of 70 degrees. So we have it as 61.08. So this is the height. So 61.08, since meters is given, we will also write here as meters. So the height between the kite and Brian's head is 61.08 meters. So this is how we use the application of angle of elevation in this example. Now in the second example, it's given that from an airplane at an altitude of 1200 meters, the angle of depression to a building on the ground measures 28 degrees. So there is an airplane which is at a height of 1200 meters above the ground, and it makes an angle of depression. That means a person sitting in the airplane, you can say, is looking down at a building, and he is making an angle of 28 degrees. Now we have to find the distance from the plane to the building. Again, I will suggest you to go for a rough diagram, draw a rough diagram to understand the question. So think that there is an airplane which is flying, and it is at a distance of 1200 meters above the ground. For example, this is the ground, and it is at an angle, it is at a height of or altitude of 1200 meters with respect to the ground. So this is the height of the airplane. Now it is making an angle of depression to a building. So think that there is a building which is on the ground, and it is making an angle of depression. Means first we need to draw the line of sight over here, and then it is making an angle of depression. So it is looking down, and here, since it is looking down, we have the angle of depression with respect to the line of sight is written this way, and that angle becomes 28 degrees. Find the distance from the plane to the building. Now this is the plane and this is the building, and to find the distance between the plane and the building, which is the horizontal distance they are asking us to find, we need to find out x, that is the distance between the airplane and the building. Now we will start by marking the hypotenuse, the opposite and the adjacent, starting with the hypotenuse, which is always opposite to the 90 degrees. So this becomes the hypotenuse. And now to mark the opposite, we need an angle inside the right angle triangle. And as we can clearly see that this is making a Z angle or an alternating angle with the ground. If this is 28 degrees, this is also going to be equal to 28 degrees. So now we have got the angle of concern, and opposite to this 28 degree is 1200, which becomes the opposite side. And the distance, the horizontal distance between the plane and the building, becomes the adjacent. Now let us see whether we can use so, we can use ka or toa. So let us start with the first one, which is so. So if we are using so, we can take sine of 28. We have the opposite, but we do not have the hypotenuse with us, so we cannot use the so. Let us check with the next one, which is ka. That is cos of 28 degrees is equal to adjacent, which we need to find, and hypotenuse, which is not given. So we have two variables to be found here, so we cannot use ka as well. So the last one which remains is toa, that is the tan. So we can try the toa as tan of the angle given, that is tan of 28 degrees, is equal to opposite. So opposite we have as 1200 divided by the adjacent. Adjacent is the one we need to find. So to find the x, we can interchange the places. X goes to the place of tan 28 and tan 28 comes in the place of x, and hence we write it as x equal to 1200 over tan 28. So let us see how much we get it through calculation. So we have 1200 divided by tan 28. So we have as 2256.87. So 2256.87 meters. So that is the distance between the building and the aeroplane. So this is how we make use of the trigonometric ratios SOHCAHTOA in solving the angle of elevation or angle of depression questions. Now let us look at the next question. The shadow of the building is 30 meters long. So they have given the length of the shadow when the angle of elevation of the sun is 56 degrees. Calculate the height of the building. Now imagine that there is a building over here and there is a sun at this point. Now when there is a sunlight, then the building will cast a shadow. This is the shadow. And the length of that shadow is given as 30 meters long. So this is the length of the shadow from this point till this point. Now the angle of elevation of the sun means the angle the sun makes with the ground is given as 56 degrees. So we mark it here as 56 degrees. This is the angle of elevation of the sun with respect to the ground. This is the ground on which the shadow is falling. They have asked us to calculate the height of the building. Now this is what is the height of the building and this is what we need to find out. Now again, since you can see this is making a right angled triangle, we go for SOHCAHTOA. So let us see if so works. And before trying out the trigonometric ratios, we have to mark the hypotenuse, the opposite and the adjacent. Now start by marking with the hypotenuse again. Since this is 90-degree angle between the building and the shadow, opposite to that becomes the hypotenuse, and 56 degree is the angle of concern. So opposite to that is the height of the building, so we make this as the opposite, and the remaining side, that is the shadow of the building, becomes the adjacent. So here we have to check what all we need. As you can see, we do not have the hypotenuse with us, so it is not required to find the SO or Ka, because as you can see the hypotenuse is not there in the diagram, so we cannot use SO, we cannot use Ka. So the last one remains is TOA, that is the tan. Tan of the angle is equal to opposite over adjacent. We have to find out the opposite and we have the adjacent with us. So we write it as tan of 56 degrees is equal to opposite. Opposite is the height of the building, which is the x, divided by the adjacent. Adjacent is given as 30. So now what we are going to do is we are going to multiply the 30 with tan 56 to get the height of the building. So x will be equal to 30 multiplied with tan of 56. So let us calculate how much we get. So here we have 30 multiplied with tan of 56 degrees. So we get here the answer as 44.47. So we can round it off as 44.5 meters. This is the height of the building. Now let us look at the part B. The length of the shadow when the sun is at an angle of 32 degrees. Now we have to find out the length of the shadow. So let me draw the diagram again. So this is the building and this is the sun, and it is casting the shadow of the building. So this is the shadow from this point till this point. So we can take the shadow now as x, and now they have given the angle of elevation of the sun to be as 32 degrees. That means the angle made by the sun with the ground. So let me draw a line. You can take it this way. So this is the angle of elevation. They have given here as 32 degrees. So we have to find out now the shadow, length of the shadow. Now we already have calculated the height of the building. That is, we got it as 44.5 meters. Because the height of the building is not changing, the height remains the same. The angle of elevation can change depending on the sun going up or sun going down. That is, it is rising or it is setting. So depending on the angle of the sun, the shadow length can change, but the height of the building remains the same. So we can use the height of the building over here as 44.5. So again we are going to use the SOHCAHTOA over here. As you can see, it is making a right angled triangle. So let us see the hypotenuse. So opposite to the 90 degree, this is the hypotenuse. Now opposite to the 32 degrees, this becomes the opposite. And the remaining side, that is the shadow, becomes the adjacent. Now again, if you see so and ka, we cannot use because it has a hypotenuse and we do not have the hypotenuse with us. So if we are using these two, we will be having two unknown variables, which is not possible to solve. Hence we will discard so and ka and we can use the toa, that is the tan. So we can write it as tan of 32 degrees is equal to, opposite is 44.5 divided by adjacent is the length of the shadow, that is x. Now to find the x, we can exchange the place of x and tan 32 degrees. So x will be equal to 44.5 divided by tan of 32 degrees. So let us calculate and see how much we get. So it is 44.5 divided by tan of 32 degrees. We get it as 71.21. 71.21 meters. So this is the new length of the shadow formed when angle of elevation is 32 degrees. So this is how we relate the angle of elevation and angle of depression with the trigonometric ratios. Now the next question is related to angle of depression. Let us see what it is asking us to do. A park has two flagpoles 20 meters apart. One flagpole is 12 meters high and the other is 27 meters high. Calculate the angle of depression from the top of the taller pole to the top of the shorter pole. Now let me draw it and show you again. Think that there are two poles. This is one pole and this is another pole. This is the taller pole and this is the shorter pole. Now the distance between the two, that is the separation is this. So this is what the distance between the two poles is. Now let us start marking the things they have given. A park has two flagpoles 20 meters apart. So the distance between these two flagpoles is 20 meters. One pole is 12 meters high and the other is 27 meters high. So obviously the taller one is this, so we will mark it as 27 meters, and the shorter one is this, so we will mark it as 12 meters. Calculate the angle of depression from the top of the taller pole to the top of the shorter pole. So now if we take the point from this to this, because we are looking from the taller pole to the shorter pole, we have to calculate the angle of depression. And if you remember, the angle of depression is always with respect to line of sight, that is the horizontal line. So here what we are going to do is we are going to draw the line of sight from the taller pole, because the angle of depression is with respect to the taller pole to the shorter pole. So you have to draw it with respect to the taller pole over here. Now they have asked us to find this angle, which is the angle of depression. So let me take that angle of depression as x. Now to calculate this, again we have to form a right angled triangle. Without a right angled triangle you cannot find it. So what I'm going to do is, I'm just going to make a line over here where the 12 meter pole ends. Now if you look at this portion, this looks like a rectangle, and we know that in a rectangle the opposite sides will be the same. That's why here, if this is 12 meters, then this is also going to be 12 meters. And if this is 20 meters, then this is also going to be 20 meters. Now, the height of the entire tall pole was 27 meters. Now, out of that, this portion has become 12 meters. So, whatever remains here is 27 minus 12, which is nothing but 15 meters. So, now if you look carefully, I have made a right angle triangle over here. So this is the one which is looking like a right angled triangle. So let me draw it again over here to make the things very clear. This is what the right angle triangle I just now created. This is 15 meters, this is 20 meters, and this is the right angled triangle. Now if I somehow find out this angle, then it is also equal to the angle of depression, because I have explained you in the earlier part where there is a z angle formed, the angle of elevation will be equal to the angle of depression. So now let me find out this angle. So before I find out this angle, I will mark the hypotenuse opposite and adjacent, which is opposite to the angle of concern, and the remaining side becomes the adjacent. Now you might have guessed out of SOHCAHTOA which we can use. Since hypotenuse we do not have, we cannot use SO and CA, we will be using TOA, that is the tan. So we will take this angle as x. Since if this angle I have taken as x, it's a z angle or an alternating angle, this angle also becomes x. So it is now tan of x degrees equal to opposite, which is 15, over adjacent, which is 20. Now to find out x, I will take the tan on the other side. So it becomes x equals tan inverse of 15 over 20. So let us check what we will get. Here we have tan inverse. So to get the tan inverse on the calculator, click on the shift and click on tan. You get the tan inverse. Put 15 divided by 20. That is 36.86, or you can just round it off as 36.9 degrees. So this is the angle of elevation. But we know that since it is forming a Z angle over here, or an alternating angle, this also will be equal to the angle of depression. So angle of depression equal to X equal to 36.9 degrees. This is the answer for this question. So it becomes really easy to find out the angle of elevation or angle of depression if you're drawing the diagrams. Without the diagrams, it will become quite hard. So use your imagination to find out how the question looks and try to solve it out.